Hello friends, today we are going to talk about kinematics. From description box you can find out ebooks and best quality handwritten notebooks. So what is reference frame? Reference frame is a set of coordinate axes with respect to which we measure the position of any particle. What is motion? A particle is said to have moved in a certain reference frame if its position vector changes. Now, what is displacement? The change in position vector is called the displacement. It is denoted by S with vector sign. Mathematically, you can write S is equal to RF minus RI, or S is equal to delta R, where RF is final position and RI is initial position, and delta for change. Now, if a particle final coordinate is 3, 4, 5 and it has undergone a displacement of S is equal to 2i cap minus 15j cap plus k cap, then find its initial coordinate. Here Ri is equal to Rf minus S, or Ri is equal to 3i cap plus 4j cap plus 5j cap minus 2i cap minus 15j cap plus k cap. So we can write Ri is equal to I cap plus 19j cap plus 4k cap. Now, if the minute hand of a clock tower is half meter long and time is 12 o'clock, then take y-axis along 12 o'clock position and find S of its tipping. 10 minute. So we can write Ri is equal to half j. From figure you can see here 0, 12 along y-axis, here 30, 60 and it's 90. Okay, and here 5 minutes. So RF is equal to half sine 60 degree I cap plus half cos 60 degree j cap, or RF is equal to half root 3 by 2 I cap plus 1 by 4 j cap after putting values sin theta and cos theta. So S is equal to root 3 by 4 I cap minus 1 by 4 j cap. Now for 20 minutes we can write RF is equal to minus half sin 30 degree j cap plus half cos 30 degree I cap. If we put values of sin 30 degree and cos 30 degree, then we get minus 1 by 4 j cap plus root 3 by 4 I cap, or S is equal to minus 3 by 4 j cap plus root 3 by 4 I cap. Now for last one, if for 40 minutes we can write RF is equal to half minus sin 60 degree I cap minus half cos 60 degree k cap. If we put values of minus sin 60 degrees and cos 60 degrees, then we get minus half root 3 by 2 I cap minus 1 by 4 k cap, or S is equal to minus root 3 by 4 I cap minus 3 by 4 k cap. Now what is distance? The length of the path in moving from one point to another is called the distance, and it is denoted by L. Now find the distance traveled in previous question. From figure we can easily find that pi by 3 into half is equal to pi by 6 meter. Note, distance is always greater than or equal to magnitude of displacement. Now what is average velocity? the ratio of displacement during a time interval to the duration of that time interval is known as the average velocity for that time interval. It is denoted by v average with a vector sign. Okay, mathematically we can write v average is equal to delta s by delta t, or one can write delta r vector by delta t. Now, second hand of a clock is 0.5 meter long. Find average velocity of the tip in 10 seconds. For this we can write Ri is equal to half j cap, or Rf is equal to half sin 60 degree I cap plus half cos 60 degree j cap. If we put the values of sin 60 degree and cos 60 degree, we can write Rf is equal to root 3 by 4 I cap plus 1 by 4 j cap. So here v is equal to s by t, so we can write root 3 by 4 I cap minus 1 by 4 j cap by 10, or root 3 by 40 I cap minus 1 by 40 j cap. Now for 15 seconds we can write, as you can see, Rf is equal to half I cap, or s is equal to half I cap minus half j cap, or v is equal to 130 I cap minus 130 j cap. Here is the average. Okay, for 40 degree, similarly you can write s is equal to minus root 3 by 4 I cap minus 3 by 4 j cap, as it represents displacement. Now average velocity v average is equal to minus root 3 by 160 I cap minus 3 by 160 j cap. Okay, if a particle travels along a straight line such that its position as a function of time, which is given by x is equal to function of time is equal to t square, where x is the coordinate of point and t is the time in second unit, then find average velocity during the time interval 1, t1 is equal to 2 and t2 is equal to 3. So v average is equal to 5 by 1, because here displacement is 5 and time difference t2 minus t1 is equal to 3 minus 2 is equal to 1. For time t1 is equal to 2 and t2 is equal to 2.1, so you can write v is equal to 0.41 by 0.1, or 4.1 meter per second. For t1 is equal to 2 and t2 is equal to 2.01, so you can write v is equal to 0.0401 by 0.01 is equal to 4.01 meter per second. For t1 is equal to 2 and t2 is equal to 2.001, so you can write v is equal to 0.004001 by 0.001 is equal to 4.001 meter per second. Now what do you think will be the answer if we keep on making the interval arbitrarily small? So it will go like instantaneous velocity is equal to 4 meter per second. Okay, now some mathematical treatment we are going to discuss here about differentiation. So what is differentiation? Let x be the sum function of time, then at any general instant of time we can talk about the ratio of change in x to the change in time for any arbitrarily small interval of time. This ratio is symbolically represented by the symbol dx by dt, and this is, we can said this by several manner, like differentiation of x with respect to t, derivative of x with respect to t, instantaneous rate of change of x with respect to t, or slope of the xt graph. So we can said these four sentence about dx dt. Okay, so mathematically the differentiation can be defined as dx by dt, where limit delta t tends to delta or very small of delta x by delta t. That is the position x of a particle varies with time as x is equal to t square. Find the instantaneous rate of change of x with respect to the general interval t. So dx by dt is equal to limit delta t tends to 0 or t plus delta t whole square minus t square by delta t. If we simplify this thing, we can write limit delta t tends to 0, or here we can expand t plus delta t square as a square plus 2ab plus b square, and here minus t square by delta t. Or we can write limit delta t tends to 0 is equal to 2t plus delta t. So if we want to remove limit, here we can omit delta t tends to 0, or using delta t tends to 0, which is very small, so we have only 2t. So dx by dt is equal to 2t. Now in another question, a particle moves according to x is equal to t cube. Using the basic definition of differentiation, find the instantaneous velocity of a particle at a general time t. So as before or previous question, we can write dx dt is equal to limit delta t tends to 0 or delta x by delta t. So limit delta t tends to 0, t plus delta t cube minus t cube by delta t. We can expand a plus b whole to the power cube as this. So t cube plus delta t cube plus 3 t square delta t plus 3t delta t square minus t cube by delta t. If you add or subtract this thing, we have limit delta t tends to 0, delta t square plus delta t square plus 3t delta t. As you know, delta t tends to 0 or very small thing, so you can write as dx dt is equal to t square. Okay, so here we have some inputs. If limit theta tends to 0, sin theta will be only theta. From this figure we can write this. Here this is the radius of a circle, and this position 1, this is position 2. The angle between position 1 and position 2 is theta. If this thing is arc is very small, we can take this thing as a small perpendicular distance or straight line. So sin theta is equal to r theta by r. Okay, so we can cancel r by r, or sin theta is equal to theta. Okay, so the minimum value of sin theta or tan theta is theta, or minimum value of cos theta is equal to 1 if delta t is tends to 0 or delta t is very small. So we can prove this thing, that is cos theta is equal to 1 if we limit delta theta is equal to or tends to 0. So we can write dx by dt is equal to limit delta t tends to 0, that is sin t plus delta t minus sin t by delta t, or sin t into cos delta t plus cos t into sin delta t minus sin delta t. Here we use sin a plus b formula. If we simplify this thing, we have only cos t. That is the differentiation of sin t is cos t. Here we take these two facts where sin delta t is equal to delta t and cos delta t is equal to 1. Now we have some list of standard differentiation formula where this column represents the function and this column represents its differentiation with time. If we have t to the power n, then its differentiation n t to the power n minus 1, sin t, its differentiation is cos t's differentiation is minus sin t, tan t's differentiation is sec square t, sec t differentiation is sec t tan t, cosec t's differentiation is minus cosec t cot t's differentiation is minus cosec square t, e to the power t differentiation is e to the power t, ln t differentiation is 1 by t, and c, which is a constant value, its differentiation is 0. Now there is some rules of differentiation. First rule, derivative of a sum is equal to sum of derivative. That is, if we have x is equal to t square plus t cube, we can write dx by dt is equal to 2t plus 3t square. Second one, a multiplied constant can be taken outside the derivative. So if you have dt of 3t square is equal to, we can write this constant value outside of the differentiation. So 3 dtt of t square, that is 3.2t or 60. The product rule of a differentiation of two variables, we can write ddt of u and v. So u constant dv dt plus v constant du dt. So if we have x is equal to t square sin t, we can write dx dt is equal to t square cos t plus sin t into 2t. In this example, if we have x is equal to e to the power t ln t, so dx dt is equal to e to the power t 1 by t, differentiation of ln t plus ln t e to the power t. Okay. Now quotient rule, that is ddt of u by v, we can write v du dt minus u dv dt by v square. So if we have ddt of 1 by cosec t, we can write minus of cosec t dot or product of with cot t by cosec square t. Okay, if we simplify this thing, we have only cos t. Now the chain rule of differentiation, if y is equal to function of gx, then we can write dy dx is equal to df by dg into dg by dx. So if we have ddt of e to the power sine square root of 3t square plus 2t plus 4, we can write e to the power sine square root of 3t square plus 2t plus 4 into cos square root of 3t square plus 2t plus 4 into half 3t square plus 2t plus 4 whole to the power minus half into 60 plus 2. You can also check this thing. In this similar manner, if we have ddt of 1 by square root of sine square t plus 2t, we have minus half sin square t into 2t whole to the power minus 3 by 2 into 2 sin t cos t plus 2. Or if we have ddt of 1 by sin square root of t square plus t, we get minus sin square root of t square plus 1 minus half into cos square root of t square plus 1 into 1 by 2 square root of t square plus 1 into 2t. So if we y is equal to t square, what will be the dy dx? We can write dy dx is equal to 2t into dt dx. Now in another question, if y is equal to t minus a into t minus b, where a, b are all constant, find dy dx. So dy dx is equal to t minus a, okay, into 1 for this thing plus t minus b into 1 for that thing. So we have only 2t minus a minus b. In another question, if we have y is equal to t minus 4 into 3t square minus 4t minus 5, find dy dx. So we can write using the product rule of differentiation, t minus 4 into 6t minus 4 plus 3t square minus 4t minus 5 into 1 due to this first term, and this is due to this second term, and we get this thing. Now if we have y is equal to 2 square root of cot t square, find dy dx. So 1 by square root of cot t square into minus cosec t square into 2t. In this problem, find the rate of change of area of a circle if its instantaneous radius is 5 cm, increasing at a rate of 1 cm per second. So the area of a circle is equal to pi r square, where r is the radius of the circle. So we are going to calculate the rate of change of its area. So dA dt is equal to r into 2r by dr dt. Okay, so here 10 pi semi square by per second. If we put the value of r, we have this. Okay, sorry, this thing is pi. Okay, sorry. Now repeat the previous question for volume of a sphere. We know the volume of a sphere V is equal to 4 by 3 pi r cube. So dV dt is equal to 4 by 3 pi into 3r square into dr dt. Okay, putting these the given values, we have 100 pi semi square per second. Now if a stone is dropped in a coil, here we can see, if a stone is dropped in a quiet lake, a ripple wave moves at 4 cm per second. Then how fast is the enclosed area in the ripples? Increases when the radius is 10 cm. So we take the lake as a circle, so its area is a is equal to pi r square. So dA dt is 2 pi r into 4, that is dr dt, which is 4. So we have 80 pi. Now the length x of a rectangle is decreasing at a rate of 3 cm per minute, and its width y is increasing at a rate of 2 cm per minute. When x is 10 cm and y is 6 cm, find the rate of change of perimeter and the area. So the perimeter we can write P is equal to 2 into L plus B. So the rate of change of its perimeter, that is dp dt, is equal to ddt of 2L plus ddt of 2B. So putting this value, we can find dp dt is equal to minus 2. Okay, for area we can write A is equal to just L into B, and the rate of change of its area is equal to ddt of L into B, or using product rule of differentiation we can find L into dB dt plus B into dL dt, or putting this given value we have dA dt is equal to 2. Now find the rate of change of volume of a cone if radius and height is changing with time. So the volume of a cone V is equal to 1/3 pi r square h, or dV dt is equal to 1/3 pi ddt of r square h, or 1/3 pi into r square dh dt plus h dr square dt. In next one, find the rate of change of a surface area and the volume of a cube of edge A if A is changing with time. So the volume of a cube is V is equal to A cube, or dV dt is equal to dA cube by dt into 3A square dA dt. Okay, and the area of a cube A is equal to 6A square, or dA dt is equal to 12A into dA dt. Now the volume of a cube is increasing at a rate of 9 semi-cube per second. How fast is its surface area increasing when the length of edge is 10 centimeter? So here dV dt is equal to 9. So dA cube by dt is equal to 9. If we differentiate this thing, we get 3A square into dA dt is equal to 9, or dA dt is equal to 9 by 300. Okay, 6 dA square by dt is equal to 6 into 2A into dA dt. If we put this value, we have 3.6 centimeter square per second. Now we are interested to know the graphical meaning of a derivative. So if we have a graph of y and t, x, like this graph, here t along x-axis and y along y-axis, and this is a curve, and here we represent this thing as delta y and this thing as delta t or delta x, and this curve is making theta angle with delta x or delta t. So the graphically the derivative is the tan of the angle which the tangent of the graph makes with the positive horizontal axis, or this is also called slope of the graph. Here we can write dy dt is equal to tan theta, or if you take this as delta x, we can write dy dx is equal to tan theta. So what are the maxima and minima of a graph? If we have a curve like this, you can see here, so this thing is called local maxima, these things are called local minima, this thing is called global maxima, or this thing is called global minima. So we can say for any smooth curve without slope rings, we see that the tangent of the curve becomes parallel to the horizontal axis at every peak and valley. This to locate the maxima and minima of any function, its derivative should be equated to 0. So at point maxima or minima, we can write dy dt is equal to 0. Okay, or its first derivative should be 0. Together maxima and minima are called the extrema. Now if the value of x for which y is extrema. So if we have a function like that, like this, y is equal to x square plus 2x plus 4, then the question is find the value of x for which y is extrema. So as we already see that at the maxima and minima point, its first derivative should be 0. So dy dx is equal to 0, or dy dx is equal to 2x plus 2, which is the differentiation of this function, and here we can find x is equal to minus 1. So if we put the value of x in this function, we get y is equal to 3. Okay, or we can also write x plus 1 whole square plus 3, and it will be the minimum when x is equal to minus 1 or delta y is equal to 3. Now if we have a function like y is equal to sin x plus 4, then find the extreme. So dy dx is equal to 0, or dy dx is equal to cos x, and from here we can find x is equal to 2 pi plus 1 into pi by 2. Okay, now for second derivative we can write derivative of a derivative is called the second derivative. Okay, so if we have a first derivative like this, its second derivative is like that, this. Okay, so if we have y is equal to t cube, its first derivative is dy dt is equal to 3t square. Its second derivative is d2y dt square is equal to 60. Okay, now the differentiating between maxima and minima. As we approach a peak moving in the direction of positive x-axis, the slope of the graph keep on decreasing, that is the rate of change of slope is negative, or the second derivative of the function is negative. So when we approach a minima, the slope keeps on increasing, and thus the rate of change of slope is positive, that is d2y dt square greater than 0. As dy dt is called the slope, d2y dt square is called curvature, okay, or kota. So find the extrema of y is equal to minus 3t square plus 2t plus 6. So its second derivative is d2y dt square or dy dt of minus 6t plus 2t or t is equal to 1/3. So its extrema point, here we can find y max is equal to minus 3 into 1 by 9 plus 2 into 1/3 plus 6, or y max is equal to 1/3 plus 6. Now if a field along a river is to be fringed around 3 sides using a length of rope 20 meter, what is the maximum area and the corresponding dimension of the field? So the area is 20 minus 2x into x, that is minus 2x square plus 20x. So the rate of change of its area dA dx is equal to 0 is equal to minus 2x square plus 20x, or x is equal to 5. So its second derivative is d2a dx square is equal to minus 4, which is negative, so it is a maxima, or a is equal to 5 into 10 is equal to 5 meter square. Find the maxima and minima of y is equal to x cube by 3 minus 3x square by 2 plus 2x. So dy dx is equal to 3x square minus 3x plus 2 is equal to 0. We have x is equal to 2 and x is equal to 1. Now we can check putting these two values after taking the second derivative of this function. So d2y by dx square is equal to 2x minus 3. Putting x is equal to 2, we have 4 minus 3 is equal to 1, which is a positive, that is at x is equal to 2 the function has a minima, and for 2 that is x is equal to 1 the second derivative is 2 minus 3 is equal to minus 1, which is a negative. That means at that point the function has a maxima. So y max is equal to 3 minus 3 plus 2, that is 2, and y min is equal to 4 minus 12 plus 2 minus 6. Now what is the maximum value of a cylinder which can be fitted in a sphere of radius r? Let the height be 2h. So as you can see here, a cylinder is fitted within a circle or a sphere. Here from figure, the volume V is equal to R into capital R square minus H square into 2H. So volume is 2 pi R square H minus 2 pi H cube. So first derivative of volume with respect to height, that is dV dH is equal to 2 pi R square minus 6 pi H square is equal to 0, or H is equal to R by root 3. So the volume is 2 pi, putting the values of H, we find V is equal to 4 pi R cube by 3 square root 3. Now what is the maximum volume of a cone that can be described in a sphere of radius r? Using this figure, we can write the volume is 1/3 pi into r square minus h square into r plus h. Okay, and the rate of change of volume with respect to height, we have h is equal to minus 1 or h is equal to r by 3. So the volume is 32 by 81 pi r cube. Now what is the maximum curved surface area of a cylinder which can be put inside a cone of radius r and height 2r? As you can see from this figure, curved surface area is 2 pi into 2r minus h into 4 by 2 h. Okay, so we can write s is equal to 4 pi into 2rh minus h square, or ds dt is equal to 4 pi into 2r minus 2h is equal to r, or h is equal to r. Now what is integration? So integration is a antiderivative thing, or we can say integration is the reverse process of differentiation. Physically it means summation of infinitesimal parts, or graphically it means area under the graph. So we have some standard result of integration. Integration of cos x dx is equal to sin x plus c, where c is our integration constant. Integration of sin x dx is equal to minus cos x plus c. Integration of e to the power x dx is equal to e to the power x plus c. Integration of 1 by x dx is equal to ln x plus c. Integration of sec square x dx is equal to tan x plus c. Integration of cosec square x dx is equal to minus cot x plus c. Integration of x to the power n dx is equal to x to the power n plus 1 by n plus 1 plus c, or integration of 1 by a square plus x square dx is equal to 1 by a tan inverse x by a plus c. Here we have some rules for integration. First rule, a multiplied constant can be taken outside the integral. As you can see here, integration of 3 cos x dx. So 3 is a constant, we take outside the integration, that is 3 integration of cos x dx, or 3 sin x plus c. Second, integral of a sum is equal to the sum of the integrals. The integration of 3 cos x plus 2 sin x dx is equal to 3 sin x minus 2x 2 cos x plus c. 3 number, integration of function of ax plus b dx is equal to 1 by a fx dx, where x is equal to ax plus b. We take here some example. Integration of cos 3x plus 4 dx is equal to 1/3 sin 3x plus 4 plus c. Similarly, you can solve these things like the first one. Okay, so do it by yourself. 2, 3, 4, 5 and 6. Now what is definite integral? If integration of function of x dx is equal to fx, then integration of fx dx with lower limit a and upper limit b, we can write fb minus fa. Here you can see integration of cos x dx with lower limit 0 and upper limit pi by 2. So we know the integration of cos x is sin x, and here we can put its upper limit first, that is pi by 2 or 90 degree, minus sine of its lower limit, that is 1. Okay, similarly, if integration of cos 2x dx with lower limit 0 and upper limit 5 by 4, we can find this thing. Okay, now definite integral by substitution. Okay, example 1, lower limit 0 pi integration of 2t sin t whole square dt. So for this we take x is equal to t square, or dx dt is equal to 2t. Here we change the variable t square with the variable x. So if we put this thing dx dt sin x dt, so it simplifies like that, that is sin x dx. Now for this we have to change also its upper limit and lower limit. If we put t is equal to 0 in this thing, we have t is equal to pi. If we put x is equal to 0, we have x is equal to pi square. For now, our new limit, that is lower limit, is 0 and upper limit is pi square. Okay, if we integrate this thing, we get this. Similarly, you can also check this integral and solve it step by step. This integral also. Okay, this one also. Okay, now using definite integral, prove that circumference of a circle is 2 pi r, or from figure we can write integration of dl 0 to l is equal to 0 to 2 pi r into d theta, where this is dl, this is the angle theta, and the radius is capital R, or 0 to l into l is equal to r into theta 0 to 2 pi, that is l is equal to 2 pi r. Now using definite integral, prove that the area of a circle is pi r square. So this is d theta, this is the angle 90 degree, and this is arc r d theta. So dA is equal to half r d theta into r, or dA lower limit 0 to a is equal to 0 to 2 pi half r square d theta. If we simplify that, we get a is equal to pi r square. For rings, we can write 0 to a dA is equal to 0 to r 2 pi x into dx, where this is the x, this is the r is equal to dx, and l is equal to 2 pi x. If we simplify, we get a is equal to pi r square. Or in the form of strips, if we have radius r, so we can write dy is equal to r cos, which is a width, and the length is equal to 2 square root of r square minus y square. So we can write 0 to a dA is equal to 2 0 to r square root of r square minus y square into dy. And if we simplify this, we get at last a is equal to pi r square by 2, which is the area of a semicircle. Similarly, we can prove the surface area of a sphere is pi r square. Okay, here this is the radius r, this is the angle theta, this is the small angle d theta, so you can write this is r d theta, and if we take this as r cos theta or this as r sin theta, so we can write ds, which is the surface area, is equal to 2 pi r sin theta, which is length, and r d theta, which is breadth. So you can write 0 to s, ds is equal to 0 to pi 2 pi r sin theta into r d theta. And after doing this, we get s is equal to 4 pi r square. Now, using integration, we can find the volume of a sphere is 4 by 3 pi r cube. Here we take this is x, this is r, and this small thing is dx. So we can write 0 to v, dv is equal to 0 to r 4 pi x square dx. So we get v is equal to 4 by 3 pi r cube. Now using integration, we can find CSA of a cone is pi rl, that is curved surface area. So from figure you can see ds is equal to 2 pi y tan theta sec theta dy. Okay, and that is 0 to s, ds is equal to 0 to h, where h is the height, 2 pi y tan theta sec theta dy. So using some small steps, we can find s is equal to pi rl. Now using the integration, we can find the volume of a cone is 1/3 pi r square h. So here dv is equal to pi y square tan square theta into dy, where r is the radius. Okay, so 0 to v, dv is equal to 0 to h dy into pi y square tan square theta. After doing some small steps, we get vy is equal to 1/3 pi r square h. Now we are going to talk about differential equation. So first order differential equation, an equation of the form dy dx, which is a function of y and x, is called a first order differential equation. The relation between y and x which satisfies the differential equation is called a solution of a differential equation. So solve the differential equation dy dx is equal to xy. So we can write dy dx is equal to dx into x, or integration of dy dx is log y is equal to x square by 2 plus c, or e to the power x square by 2 plus c is equal to y, or y is equal to c into e to the power x square by 2. Now solve dy dx is equal to 2 cos x plus 1 by y. So integration of y dy is equal to integration of 2 cos x plus 1 into dy, or y square by 2 plus is equal to 2 sin x plus x, or y is equal to square root of 4 sin x plus 2x plus c. Now we are interested to solve differential equation with boundary condition. So solve dx dt is equal to t, where at t is equal to 0 and x is equal to 3 is the boundary condition. So dx is equal to t dt, where 0 to t and 3 to x. So we get x minus 3 is equal to t square by 2 minus 0 square by 2, or t is equal to square root of 2x minus 6. Now if we have dx dt is equal to cos t, our boundary condition is t is equal to 0 and x is equal to 5, we can write 5 to x dx is equal to 0 to t cos t dt, or x minus 5 is equal to sin t, or x is equal to sin t plus 5. Now if we have dv dt is equal to a, boundary condition t is equal to 0 and v is equal to u. So dv 0 to v, a dt 0 to t, sorry, dv is equal to u to v. So you can write v minus u is equal to at, this is 0 to t, or v is equal to u plus at. If we have dx dt is equal to u plus at, t is equal to 0, s is equal to 0. So we can write 0 to s ds is equal to 0 to t u plus at into dt. So we can write s is equal to ut plus half at square 0 to t, or s is equal to ut plus half at square. Now if we have v into dv ds is equal to a, boundary condition is s is equal to 0 and v is equal to u, you can write u to v, v into dv is equal to 0 to s, a into ds, or v square by 2 u to v, a into s, 0 to s. So we can write v square minus e square is equal to 2as. Now what is instantaneous velocity? The average velocity for an infinity or infinitesimal small decimal interval of time in the vicinity of a given instant of time is called instantaneous velocity at that time. Thus, if ds be a small displacement in a small time interval dt, then the instantaneous velocity at that instant is given by v instantaneous is equal to ds by dt. Now the displacement of a particle is given by s is equal to 3t square plus 2, then find its velocity at t is equal to 3. Okay, so v is equal to ds dt, so ds dt is equal to 60 from this, and t is equal to 3, so you can write 18 meter per second is the velocity of a particle. Note, by default it is assumed that at t is equal to 0, s is equal to 0. Now the velocity of a particle is given by v is equal to 2 cos t, then find s. So s is equal to dv dt, or ddt of 2 cos t, or s is equal to 2 sin t. Now what is average acceleration? The ratio of change in velocity in a given interval of time to the duration of that interval is called average acceleration. Mathematically, we can write, if delta v be the change in the velocity in a time interval delta t, then a average is equal to delta v by delta t. Note that for any trajectory, the average velocity is along the chord of the trajectory and the instantaneous velocity is along the tangent. Okay, now which point is the average velocity in the same direction as the instantaneous velocity? Okay, so from figure or curve, this is our curve, you can find that this point has the same average velocity as the instantaneous velocity. Okay, now what is average speed? The ratio of the length of the path covered in a time interval to the duration of that time interval is called average speed during that time interval. Mathematically, V average is equal to delta L by delta T. Note, by the definitions, it is clear that magnitude of average velocity is always less than or equal to the average speed. Now, what is instantaneous speed or V? Let dl be the small distance covered by a particle in a small time interval dt. Then the instantaneous speed is given by V is equal to dl by dt. Note, when the time interval becomes very small, in the limit, the chord length approaches the arc length, that is dl is equal to ds. Thus the instantaneous speed is same as the magnitude of instantaneous velocity. Now, what is instantaneous acceleration? The average acceleration for an infinite decimal interval of time is called the instantaneous acceleration. Mathematically, we can write A in is equal to limit delta t tends to 0, delta v by delta t, or A in is equal to dv dt. In case of motion along a straight line, we generally omit the vector sign and write A in is equal to dv dt. Now, the differential equation governing motion along a straight line. We already know V is equal to ds dt and A is equal to dv dt. So, A is equal to dv dt into ds dt, or dv ds into ds dt, or A is equal to V into dv ds. Now, if a particle is moving along a straight line, say along x-axis, then its displacement at a general time is given by s is equal to x minus x0, or ds dt is equal to dx dt minus 0, where x0 is a constant value, or v is equal to dx dt. Now, using the basic differential equation, prove the basic equation of motion along the straight line with uniform acceleration. Assume at t is equal to 0, s is equal to 0, and v is equal to u, or s is equal to s0. The first equation is v is equal to u plus at. Second is x is equal to ut plus half at square. Third equation is v square minus u square is equal to 2as, and fourth one, x is equal to x0 plus ut plus half at square. We put v is equal to dx dt, 0 to t u plus at into dt is equal to x0 to x dx, or ut plus half at square, 0 to t is equal to x minus x0, and x is equal to x0 plus ut plus half at square. And equation 1, 2, 3 we have already proved above the notes. So you can find these three equations here, 1, 2, 3. So this is our first equation, this is our second equation, and this is our third equation. Okay, so already we did this equation. Now general motion with a uniform acceleration, we can write equation 1, s is equal to ut plus half at square, v is equal to u plus at, v square minus u square is equal to 2as, or v dot v minus u dot u is equal to 2a dot s, or r is equal to r0 plus ut plus half at square. Displacement in nth second, we can write Sn is equal to un plus half a into n square. S n minus 1 is equal to u n minus 1 plus half a n minus 1 to the power square, or S nth is equal to u plus half a into 2n minus 1. So linear equation or linear motion under gravity, we can write S is equal to ut minus half gt square, because here a is equal to minus g, v is equal to u minus gt square, and v square is equal to u square minus 2gh. Now a ball is projected vertically upwards with initial speed u. Find the maximum height. So the maximum height from this equation we can find u square by 2g. Time to reach maximum height, so using above equation we can find time is equal to u by g, and the speed, that is speed at the half the maximum height, we can find v is equal to square root of u square minus u square by 2, which is v is equal to u by root 2. Now a ball is dropped from a balloon going up at a speed u. When it is at a height h, how long will the ball take to reach the ground? So using above equation we can find minus h is equal to ut minus half gt square. Here s is equal to minus h. Okay, if you simplify this, we have t is equal to u plus minus square root of u square plus 2gh by g. Now a stone is thrown upward with an unknown speed. What is its speed before reaching maximum height? So using above equation we can write v is equal to u minus g into 1, or v is equal to minus g, or v is equal to minus g, or v is equal to u minus gt, and v is equal to u g into ug by minus 1, or v is equal to plus g. Okay. So drops are falling at a regular interval from a roof as shown in the figure. Okay, find the ratio of L1, L2, L3 when another drop was just going to fall. So water drops are falling, and this length is L1, this length is L2, and this length is L3, and for this length time is t, for this length time is 2t, and for this length time is 3t. So you can write s1 is equal to minus half gt square, s2 is equal to minus half g 4t square, and s3 is equal to minus half g 9t square. So L1 is equal to minus half gt square, L2 is equal to minus half g3 square, g3t square, and L3 is equal to minus half g5t square. So from this we can easily found f1 L1 is to L2 is to L3 is equal to 1 is to 3 is to 5. Now a ball is dropped from an unknown height. It takes t0 second to cover the last h meter of its fall. Find the height from which it was dropped. Take t0 is equal to 0, 2, and h is equal to 6. Okay, so we can see this figure where this is small h and this is capital H. So v square is equal to 2gh, or v is equal to square root of 2gh, or minus h is equal to square root of 2gh t0 minus half gt square. If we put this value, we find h is equal to this, and h plus small h is equal to 48.05 meter. Okay. Now if ferry boat, after starting its engine, moves according to the velocity v is equal to v0 t1 square by t square, how much will be the total distance traveled by the boat if t1 is the time at which engine is start? So we can write 0 to s ds is equal to 4 to infinity or v0 t1 square by t square into dt, or s is equal to this and s is equal to v0 t1. Now the velocity of a particle is given by v is equal to a e to the power ks, where a and k are the constant and s is the displacement. How does acceleration depends on the displacement? So a is equal to dv ds into v, and if we put this value, we get a is equal to a e to the power kx into r into a e to the power rs, or a is equal to a square e to the power 2 ks into k. Okay, so in the previous problem, find the displacement, okay, as a function of time. So v is equal to a e to the power ks, or ds dt is equal to a e to the power ks, or 0 to s ds by e to the power ks is equal to 0 to 2 t a into dt. If we integrate this thing, we get s is equal to ln into 1 minus kt by minus k. In the previous problem, what is the acceleration as a function of time? So a is equal to, we already got this thing. If you integrate, then we can find v is equal to ds by dt is equal to this thing, and we know acceleration is nothing but dv dt. So after putting this value, we get a is equal to this thing. If v is equal to square root of kx, find the acceleration as a function of displacement. Now we can write a is equal to a into dv ds is equal into v. Okay, and after putting this value, actually there is small mistake. We can write a is equal to dv dx into v, and after putting this value, we get v square k by 2. Now velocity of a particle is given by v is equal to 70 square minus 5. Find the displacement as a function of a acceleration. So we can now understand v is equal to ds dt is equal to 70 square minus 5, or 0 to s ds is equal to 0 to t 70 square minus 5 into dt. From here we can easily find t is equal to this, t is equal to a by 4, or s is equal to this. Okay, now acceleration of a particle varies as a is equal to minus k root v. At the initial moment, the velocity of a particle is v0. How much distance will it cover before stopping, and how much time will it take to cover that distance? So we can write a is equal to this, and we can write also 0 to s ds is equal to v0 to 0, that is root v by minus k root v into v. So then we can find sf is equal to this, and here a is equal to dv dt, or 0 to t dt, or v0 to a 1 by a dv, and then we can find t is equal to 2 root v0 by k. Okay, here one thing, area of a triangle. So if this is q, this is p, and this is 90 degree, and this is theta, angle between p and q, we can write this thing as a p sine theta. So the area of a triangle is half p sine theta into q, or half p cross q. So for now, this is the end of our kinematics notes. Okay, so you can practice from this note and do comment if you have any doubt. Okay, so for next video we are going to discuss this next thing in the next video. Till then, take a break. Okay.